Okay, I'm just going to run through the first couple you sent me kind of quickly because you have most of the stuff right. So I know you put in things in your calculator correctly. Just going to try to figure out maybe what happened with your specific questions. So this first one, you want to test the claim at a 0.02 significance level. So we know the population standard deviation, so that's going to be a z-test in the calculator. So we have in our stat menu, we're going to go over to z-test. We're going to put in our stats. We're going to plug in the mu is 59.2, the null mu. Our sigma is 7.3. Our x bar is 61.6. And our sample size is 50. We're trying to show that our mu is greater than the null. So we're going to calculate. So our p-value is 0.01004, but right into 4 decimal places would just be 0.01. I'm not quite sure how this value occurred. Maybe you did a double. Let's see here. It's still in there. Maybe this is from doing a two-sided. I'm not sure. Nope, I'm not quite sure what exactly happened, but that's going to be your p-value for question 1. Okay, question 4, same thing. I think you might have just rounded wrong. Let's check this one. We don't know standard deviation, so we're not going to use a z-test this time. We're going to use a t-test. So we have the t-test. We're inputting stats. Our mu is going to be 80.6. X bar is going to be 81.6. Our standard deviation of the sample is 9.7. And our sample size is 735. And we want to do a right tail test. And we're going to calculate. Maybe the issue is happening when maybe you're using the wrong test. Maybe you were using a z-test here, and this was what you're using for sigma. But if you don't know sigma, if we do not know sigma, that implies we have to use a t-test. If we do know sigma, we're going to use a z-test. That might be the issue, actually. So my p-value for this question is going to be 0.00266. 4 decimal places will be 0.0027. Okay. Question 5, same thing, except we still don't know sigma. All right, so we're going to use a t-test. But we don't have x bar or s. We do have data, though. So the first thing we're going to do is plug this data into L1, because we can use data from a list when we're doing these tests. So I'm going to go to edit. Just plug in the data as it is, 74.4, 36.9. 62.8, 83.4, 95.4. So now once the data is in, we're going to go back to stat, over to tests. We're going to do a t-test, but instead of entering statistics, we're going to enter data. So we're going to click that at the top. Our null mu is 72.1. Our list, the data we plugged in was from L1. Every one of us has a frequency of 1. We're trying to show a two-tailed test not equal. Now we will hit calculate. So our t-test, our test statistic is going to be negative 0.152. Our p-value is 0.8863. So when we compare the p-value to our alpha, our p-value is much larger than alpha. So p is larger than alpha. So you can remember this way. If p is low, we reject HO. So if p is lower than alpha, we'll reject the null. But since p is greater than alpha, we don't reject the null. It's greater than alpha. And then this question says reject, accept, or fail to reject. The answer is never going to be accept. You don't accept the null ever. It's kind of like when you go to court. You don't say someone's innocent, you just say someone's guilty or not guilty. We're not saying they're innocent, we're just saying there's not enough evidence to prove that they are guilty. So we can't reject the null, so we fail to reject it. So that means we can't prove the alternative. We cannot prove this. So there is, so I think at the bottom, there's not sufficient sample evidence to support the claim that the population mean is not equal to 72.1. Not enough evidence to prove this. So usually your conclusion is always going to be written in terms of the alternative, whether you can or you can't prove that. In this case, we can't prove it, so it's going to be this guy. If we could prove it, it would be C, but since we can't prove it, it's option D. Okay, question 9. Same thing. They give us all the stuff we need. Let's see here. Shareholders replying in protest claim that the mean tenure for chief executive officers was at least 9 years. A survey of 125 companies reported in the Wall Street Journal found a sample mean tenure of 8 years. So our mu, our x bar, is going to be 8. Standard deviation is 4.6. We don't know sigma. So that's going to be a t-test. T-test using stats. The null is 9. X bar is going to be 8. Sigma is 4.6. Size of the sample. Let's see here. Wall Street Finance sample mean tenure. Oh, 125. 125. Missed that. We're trying to show that it's less than. We're going to calculate. So our test statistic is negative 2.431. P-value is going to be 0.0083. Our alpha is 0.10, so our p-value is less than our alpha. So that would mean we could reject HO, so there is sufficient evidence to show the alternative. Sufficient evidence to show that. Let's just jump back to that so I can show you. Question 9. We reject the null. So there is sufficient evidence to show the population mean is less than 9. Okay. And number 10, let's see here. Okay, 2 more. Number 10, test the claim that the mean GPA of 9 students is smaller than 2.6. Okay, so we're talking about means. So anything you see with a P, that's proportions, proportions, proportions. We're looking for the fact that it's smaller than 2.6. So this is greater than 2.6, not that. Not equal to 2.6, not that. So it looks like our answer is going to be this guy right here. We're trying to show something is less than something, so that's going to be left-tailed. And then we just plug in everything into our calculator. We don't know, based on a sample of 35 people, the sample mean GPA. So we don't know sigma. This is going to be a t-test again. So we have the null is 2.6. X bar is 2.55. Standard deviation is 0.04. Size of the sample is 35. And we want to show that it is less than. Calculate. Our test statistic is negative 7.395. 2 decimals will be negative 7.40. P-value. This is 7.0995 times 10 to the negative 9. With the decimal place over 9 places, that means it's going to be 8 zeros and then a 7. So if I'm rounding it to 2 decimal places, that's just going to be 0. 0.00, or just, you don't have to write these, just 0. Basically, what happens is impossible, so it's definitely less than our significance level, so this is going to be, we reject the null hypothesis. So we can say, there is sufficient evidence to show the alternative. Okay, and the last one, I think you just said your p-value. I believe you probably did this one right. It's just the p-value had a scientific notation. Let's just run through it real quick. Uh, we don't know standard deviation, so this is going to be a t-test. So we have mu is 87.8, x bar is 89.3, standard deviation is 11.7. Sample size is 630. Trying to show it's greater than, and you calculate. Yes, so you'll notice you have the same thing here, except there's that e to the -4. Move the decimal place over 4 places. So this is going to be 0.000678. 4 decimal places would be this guy. So round it up to 0.0007. You just missed the e to the -4.